Question 8 of the Maths Paper 1 will be based on differential calculus. Calculus is a broad topic that consists of two parts. Part 1, differential calculus, normally called differentiation, and Part 2, integral calculus, commonly known as integration. To give a perspective of how big calculus is, when you study any of the engineering courses, basic mathematics or basic physics, it takes about 3 years to cover the topic of calculus. In high school, we only study a small subset of calculus. Probably that's the reason why it is a very easy topic for you guys. Calculus is a powerful discipline because it has direct applications in medicine, earth sciences, statistics, and economics. I dedicate this credit to a great mathematician, Sir Isaac Newton, one of the pioneers and inventors of calculus. The very first question, which is question 8.1, says to us that differentiate f of x from the definition of derivative, that is, the first principles, if our function is defined by that equation there. Now let us break this question and see what they really want from us. The word differentiate simply means that we have to change the function of f to a new function. We are distinguishing it to a new function, and we have to do that by using the definition of a derivative, what we call first principle. So the word derivative again simply means derive. So we have to derive a new function from the function that we're given f. And we do that process through the first principle. Now the definition or the first principle that we use is an equation that looks as follows. F prime f of x is equals to the limit of f of x plus h minus f of x as h approaches 0. We also divide it by an h there. Now this formula is a formula that will take the function that we are given and change it to a new function. That's what we call it a derivative. And we use here this small prime to show that we are finding a new function. You know, this is not f of x anymore. Now from here, we'll just run the operation using this equation. We are going to then say the limit of, remember my function here is given as f of x is equals to minus x squared plus 4x plus a2. So here it means where we see the value of x, we are going to put x plus h. So this means here I'm going to have a negative x plus h all squared. So this is this first part here. I've put the x plus h. The second part will be minus 4x plus h. So this is this part here. We have replaced the x with an x plus h. And we still have a 2 there. Now we are going to put the negative here. So this is this negative there. And we're going to write the whole of our original function. Now you have to notice that this function here, there's a negative outside, and this is a trinomial. That means that this negative affects everything in that function. So we're going to put a bracket there so that we are able to get the correct answer there. And we are dividing all this by h, and we're saying h should approach 0 here. Now from here, this question becomes very, 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 very boring. So now here it means I'm going to continue to say the limit. Now here I'm going to expand this guy here, and when we expand this guy, we're going to start first by saying x squared. then we're going to get the x squared there, but there's a negative outside there, so I'm going to immediately multiply by that negative. The second step is going to be taking the 2, multiplying it by the x, and also multiplying by the h. So I'm going to have a 2 times x times the h, and this should give me 2xh. But we still have a negative outside here, which will multiply this whole term here, and that means I'm going to have a minus 2xh. Now the last part here is that we're going to square the h here, so that I'm going to have h squared as the last term there. But again, we have a negative here, which is going to multiply that h squared, and going to have a negative h squared. And the second part then would be expanding this. And to expand this is relatively easy, because we multiply the 4 here to get 4x, and we multiply the 4 there to get 4h. So this simply means now I'm going to have a 4x plus a 4h, and we still have the 2. And this one also is very easy, because we just multiply the negative here inside that trinomial, so that now I'm having positive x squared minus 4x minus a 2, and all this is divided by the h as h approaches 0. Now, at this stage, you would come to realize that there's a couple of numbers that actually would cancel each other. If you look at the x squared here, so let me fix my division line here. If you look at the x squared here, it will cancel with the x squared. If you look at the 4x, it will cancel with the negative 4x there. And if you look at the 2, it will also cancel with the 2x. Now let me write what I'm left with now, so that this thing is simplified, or it looks a little bit better. We are left with negative 2xh. We also have the plus 4h and negative h squared. So I'm left with this guy, and this one here. And all this is still divided by an h as h approaches 0. Now at this stage, you can really divide the whole thing by an h, so that we are going to have the limit of negative 2h xh plus negative 4 over h minus h squared over h as h approaches 0. And you would see that the h would cancel each other out, and here I'm only left with 1. And I'm going to then have the limit of negative 2x plus 4 minus h as h approaches 0. Now, the next step, really, we're going to use a substitution method of limits. So this means we are going to have here a negative 2x plus 4 minus a 0. Now, what we mean here, we're saying that h approaches 0, but h is not equal to 0 here. It is a number that it is approaching. And when you simplify this, it will then give you the derivative of our function, which is going to be a negative 2x plus a 4. Now, you have to look at the difference between this new function that we have and the function that we started with here. Can you see that this is a parabola? This here is a parabola, and the function that we have derived, the function that we found, is a straight line. So it means when we take the derivative, or when we differentiate a parabola, we get a new function called a straight line. And that's why we call this whole process differentiation, or the derivative. This question is usually marked out of 5 marks, and what they really mark on this question is doing your correct substitution there. They give you 1 mark for taking time to simplify, grouping your terms and all those things. And they also give you a mark here for dividing, or maybe moving from this part to that part. So we already have here 1, 2, 3. Obviously, they'll give you a mark for the final answer. Now question 8.2 says here, find the derivatives of the following functions. And they give us 3 different functions here. Now this question is really the same as 8.1, except here we're going to use rules. Remember that our first principle is actually an equation from which all the differentiation rules are derived from. So all the differentiation rules, they come from the first principle. The thing is that the first principle is long and we can't always use it. That's why we have done these rules that are short and help us to find derivatives quickly. So here basically we are going to do the same thing but using rules now. So when you look at 8.1, we are given the function f of x is equals to x to the power 9. Now to find this derivative, we are going to use a power rule really, where we're going to take the 9 and bring it down here. It's going to multiply the 1 there, so that we have 9x. And then we're going to subtract the 1 here. And this means I'm going to have 8 at the top there. And that's the derivative. That's why this question is only 1 mark, because there isn't really much that we're doing there. The second equation, (8.2.2), we are given here y is equals to x to the power 3 plus 8 all over x plus a2. Now when you look at this question, you can see here at the top here that we have what we call the sum of a cube. We're actually dealing with the sum of a cube. And the sum of a cube is defined such that if you have a to the power 3 plus b to the power 3, this is the same as having the a plus the b multiplied by a squared minus the product of a and b, which you're going to have a and b here, plus b squared. You know, this formula is the same as the difference of 2 squares or the difference of 2 cubes, right? Because here x to the power 3 plus 8 is the same as writing it as x to the power 3 plus 2 to the power 3 there. And this means now I can expand this as what? X plus 2. Then here I'm going to have an x squared. Then here I'm going to have a 2, a minus. So this is going to be a minus 2x because I'm just multiplying these 2 and the x. And the last part would simply be a plus 2 squared, which is a 4. So we're going to square the 2 here. Remember, we're squaring the b there. Now I'm going to take this factorized part here and put it right here. I'm going to expand that so that now I'm having an x plus a 2. Then I'm having an x squared minus 2x plus a 4 all over x plus 2. Now when you look at this, you can see that the x plus 2 and the x plus 2 would cancel each other, so that now we have our y to be simplified as x squared minus 2x plus a 4. And now we are ready to take our derivative. It's much more easier to take the derivative when this function looks like this. So our derivative would be the dy dx is equals to 2x minus a 2, because the derivative of a constant is just a 0 there. So all of this is really out of 3 marks. We are going to get a mark for doing the factorization, and simplifying this to get to that. That will be 1 mark. And we get 2 marks for applying our differentiation rules here. Remember, we applied 3 rules here. We took the derivative of x squared, the derivative of negative 2x, the derivative of 4. All of that should be 2 marks then. The next question, which is 8.2.3, is given by the differential operator of 5 over the fourth root of x squared plus 2 over 3x, all this to the power negative 2. Now, there's a couple of things that we need to remember when we do this question. The first one really is the fact that if you have the nth root of m, this is the same as having a to the power m over n. So I'm going to change this to that. That's the first thing. The second thing that we need to observe is that if we have a over b all to the power, let's say, negative n, this is the same as having b over a to the power n. So this is how I change this positive to a negative there, and I'm going to apply that there as well. So these are just our rules of exponents and sets. Now, to then solve this question, that's the first thing that we're going to do. We are going to say here we have the differential operator. Remember, I haven't yet started taking the derivative, so I'll still keep the dx here. So we have a differential operator of, here we're going to have a 5 over x to the power 2 over 4. And we're having plus here 3x over 2 to the power positive 2. Now, the next step following this really is to use the rule that says if you have a to the power, let's say, n, this is the same as having 1 over a to the power n. Now, I'm going to do the reverse of this rule for this. I'm going to take this to the top so that it becomes negative now. Because remember, this is the same as having 1 over x to the power 2 over 4. So I can really take this back by saying this is x to the power negative 2 over 4. And just by the way, the 2 over 4 is the same as 1 over 2. We're also going to change that as well. So perhaps that's the first thing that I can do here. I'm going to say the differential operator again is going to be here the 5x to the power 1 over 2, the negative 1 over 2. Remember, this would be 1 over 2, and when I take it to the top, it's going to be a negative there. And we are adding this to this part here, but this part also I just want to apply a rule that says that if you have a over b to the power n, it is the same as a to the power n and b to the power n. So this rule says that you multiply this here and that. So the exponents here, a to the power 1 multiplied by n, it will give you a to the power n, and the same we do there with a b. So this means for this specific exponent there, we are really going to expand. So now this would mean now that I'm going to have a 3x to the power 2 all over 2 to the power 2, which is a 4. And we're going to close the bracket there. Now, the last bit that is left is that of a rule where we're saying a times b to the power n is the same as a to the power n times b to the power n. And I'm going to apply this here. I'm going to multiply this 2 here and that 2 there using that rule. And so this will then now simplify to dx is a 5x to the power 1 over 2 plus, here we're going to have a 9 and x squared over a 4. Now when we are here, we are ready to then take our derivative, which will be given by, now because now I'm taking the derivative, I'm going to remove the differential operator there, the dx, so that now we are going to then take the negative 2 and we multiply it with the 5, and this will give us a negative 5 over 2 x to the power. Remember, we are subtracting a 1 here when we take the derivative. And we know that 1 can be written as 2 over 2. So this means I'm having a half minus 2 over 2. And that should give me a negative 3 over 2. Plus the derivative of this would be 2 times 9 over 4. 2 times 9 over 4 should indeed give me a 9 over 2, because really the 2 here would cancel with the 4 so that I have a 2 here. But again, we're subtracting a 1 there, so 2 minus 1 should indeed be a 1. So normally we just write that as an x. And this is our derivative. You are allowed to leave the answer here, or if you like, you can simplify this further so that it then goes back to the function where we to the exponent where we're going to have a positive exponent. So this is going to be negative 5 all over a 2 the square root of x to the power 3. Because remember, this would go down at the bottom, it will become positive. Then I bring back the square root there. And indeed, this is just as 9 over 2x. And all that you need to solve this question is 4 minutes for 4 marks. Why? Because you will get here a mark for, you'll get 2 marks for applying you'll get a mark for applying the rules of exponents, all these rules that I've explained here. And you'll get a mark for simplification, for simplifying and grouping your things and all that. And the other 2 marks will come from finding this derivative and that derivative. Now, you can do this question with less steps, maybe 3 steps or so. I'm only spending time and expanding on it because I want to explain every process to assist you with the preparation for your exam. So, you can jump steps here. Now, the last question of question 8 would be question 8.3. Where we are told that the tangent to the graph y is equals to f of x at point A, which is given by 8 and 6, passes through another point, which is B, and is given by 5 and a 5. With this information, they say here, determine the equation of the normal to the graph at point A. All time often, you will get this type of questions, and they are very easy to actually deal with, just that they look tricky. Now, let us try to break this question down. We are told here that we have a function y is equals to f of x. I always give advices to students or learners that if you have this type of questions, try to do sketches so that you can visualize what they're talking about. Once you are able to see that picture of what they're talking about, it becomes easy to solve these questions. So I'm going to draw a rough, quick sketch of what could be happening here. Suppose that I say my function has a shape such that it looks as follows. Let's say this is our function y is equals to f of x. And we say here this is point A. Can I improve perhaps on my curve here? Can I improve on my curve? Now we are saying this here is point A, which is given by 8 and a 6. Now we are told that on this graph y is equals to f of x, we have a tangent at point A, so that it moves like that. Now somewhere here on the graph we have point B, which is given by 5 and a 5. So this is 5 and this is 5. So remember, here we're having an 8 and we're having a 6 here. So this is what we're basically given. We have the curve y is equals to f of x, and we have a point A here on that curve. So the tangent passes through that point. There it is. And they're saying here it also passes through another point B. So this is another point B that is on the tangent. This point is on the tangent. It's not on the curve necessarily. Now they further say here that, well, what we are requested is to find the normal to the curve. Now, the normal would be a line that is perpendicular. You know, the word normal means perpendicular. Perpendicular. So it means it makes a 90-degree angle. So the line that will make a 90-degree angle with the tangent would be a line that has to actually sit like this. And it should make a 90-degree here. So this is the tangent, meaning the gradient of the tangent. And this is the normal. So that will be the gradient of the normal. So these two lines, they make an angle of 90 degrees there. We are requested to find the equation of this line. I think when this question is like this, it then becomes very, very, very boring to deal with. Because one can even quickly think of analytical geometry, if you like. You know, we can say using these 2 points, A and B, I can find the gradient of the tangent. So this means I'm going to firstly construct the gradient of the tangent to be given by y2 minus y1 all over x2 minus x1. Where I'm saying I'm using point A and point B. Now this would mean now that I'll say 6, here is my y value on A, minus 5, which is my y value on B, divided by the 8, which is the x value on A, minus the 5, which is the y value really on point B. And when we simplify this, we can see that we are going to have a 1 at the top divided by the 3. So this is therefore the gradient of the tangent. This tangent here has a gradient of 1 over 3. However, we know that if two lines are perpendicular or they're normal to each other, you know, they make a 90-degree angle there. The product of their gradients is equals to minus 1. So this is to say the product of the tangent, the gradient of the tangent times the product of the gradient of the normal line, the perpendicular line, is going to be negative 1. Now this equation allows us to then find the gradient of the normal line, which will then therefore be given by a negative 3, because I just multiply the whole thing here by a 3. What I do on the left, I do on the right, and I should get that. Guys, we are looking for the equation here of the normal at point A. So we can see that the normal passes point A here. And I now have the gradient of the normal. We now know that the gradient of the normal is equals to a negative 3. All that we're going to do is that we're going to use this point and the gradient to then find the equation. There are fundamentally two ways of finding this. One of the ways is that I can use the equation y minus y1 is equals to m of the normal line, x minus x1. Then I'm going to use point A, which is defined by 8 and a 6. So I'm going to have y minus a 6 is equals to a negative 3, x minus the 8. And this should narrow down to the fact that I'm multiplying this is going to be a negative 3x. And here I'm going to have the negative 3 times negative 8, which will give me a negative 24. Now I have a negative 20. Well, I'm having a positive 24 because negative and a negative will give me a positive 24. Then I'll take this 6 to this side, negative 6 to this side, so that it becomes a plus 6. And when you say here 24 plus a 6, you really should get a 30. And that is your equation. You can always use the equation y is equals to mx plus c and use the same point A, which is 8 and a 6. You should be able to get the same answer that we got here. Now, this question will be worth 4 marks. The very first mark that you're going to be awarded here is to find the gradient of the tangent, finding the gradient of the normal line. And the substitution here really would give you 1 mark, and you'll get the final mark there for finding the equation of that line.